Well, welcome back, you guys. We're going to take a look today at trig identities, verifying trig identities. And so, first, we're going to start out just kind of reviewing um, a couple problems from pre-calc and see how it plays into the same approach with trig expressions. So, let's say we were factoring this 30x cubed plus 42x squared. And let's say we're like, well, what's the greatest common factor of 30x cubed and 42x squared? In other words, what's the GCF of 30 and 42? You say, well, that's 6. And what's the greatest common factor of x cubed and x squared? You say x squared. So 6x squared is the most I can take out of each of those. And it would leave us with 5x plus 7. And if you notice, if we check our factorization, if we distribute it back, it should give us the same thing, right? There's our 30x cubed, there's our 42x squared. And so we're like, yep, there it is, right? So factor out the greatest common factor. Well, similarly for trig expressions, so if you look at this next one, I have 80 sine to the fourth of x. In other words, I have 4 of these sine x's. And minus 30 sine of x. So I know I can take out, it's kind of like if sine was u, it's kind of like factoring that, right? What's the greatest common factor of 80 and 30? And you'd say, well, 10 is the most I can take out. And what's the greatest common factor of u to the fourth and u? And it'd be u. And then you'd have u, 8, u to the third minus 3, right? Well, same thing, except we're doing it with the sine. And so we're going to take out a sine from each of them. We're going to take out a 10. So 10 and one of the sines. And so what would we be left with? In other words, what's 80 sine to the fourth x divided by 10 sine x? That leaves you with 8 sine to the third x, all right? Sine of x quantity cubed. And then minus 3. And then we're all done. We just factored that. So how about with a trinomial, quadratic trinomial? If we were factoring x squared plus 13x plus 36, I like to backwards FOIL is how I do these. So I say, well, I know it's got to be x and x. And then I'm going to try factors of 36. Factors of 36, I could try 1 and 36. And remember, it's a positive 36. So it's either a positive 1 and a positive 36 or negative 1 and negative 36. I could also try 2 and 18 or negative 2, negative 18. I could try 4 and 9. Well, if you guys were trying this, you could punch it into the chat there. Which one would you try? Yes, the comment was we try 4 and 9. And we know it's either got to be a positive and a positive or a negative and a negative. And of course, we'd check it, right? If we did a negative and a negative, we'd see that, oh, we're getting this wrong because in the middle, I have a minus 13x, right? So I'm like, oh, that's not minus 4, that's got to be plus 4, plus 9, and so on. And then we check that one, and we're like, oh, that's the one, right? So it's only the positive 4 and the positive 9 that works on that. So again, that's a backwards FOIL. Well, you could do that with trig expressions too. So let's say you have a cosine squared minus 13 cosine x plus 42. You could put 1 here, it'd be the cosine and a cosine, right? And if you want to also, you can also go to the side, if you want to just let u be cosine of x, this is the same as u squared minus 13u plus 42. But make sure if you factor it that way, that you put the cosine back in at the end, right? And then you say, well, what are factors of 42? 1 and 42 is not going to work. 2 and 21 is not going to work. How about 6 and 7? Oh, that'll work. And it's got to be a positive times a positive to give you 42, or a negative times a negative. And hopefully you recognize it's a negative times a negative. And if not, you try it and you check it and so on. So this will work out for you. Again, make sure you check it. Cosine times cosine is cosine squared. Cosine times negative 7 is a negative 7 cosine. Negative 6 times cosine is negative 6 cosine. And negative 6 times negative 7 is positive 42. And so we have cosine squared minus 13 cosine x plus 42. So, like I said, there it is, all factors. So it is correct, right? Make sure you FOIL to check that. Again, I like to backwards FOIL on these. So now we've got a 6x squared as our first term. So I'm either going to try 6x and 1x, or I'm going to try 3x and 2x. And I'm going to go with a 3x, 2x first. And then I'm going to look for factors of 20. So I'm either going to try like 1 and 20, or maybe I try 2 and 10. Let's try 2 and 10. It's got to be plus plus or minus minus because it's a positive 20. And I'd check it and I'd be like, okay, that's 6x squared. That's a 30x. That's a 4x. That's a 20. I got 34x in the middle. That's not my 23x in the middle that I need. So I'm not going to try 2 and 10. How about let's switch that up. Let's try maybe, how about 4 and 5? Let's try 4 and 5 now, and then I'm going to check that one. I FOIL that. Let's see if that one works. 6x squared, 15x, 8x, 20, and I'm like, oh, there it is. There's my 23x. Anyways, you got a lot of options on this one. Because that first term is not just x squared, it's 6x squared, right? So if after you've exhausted them all with 3x and 2x, you can then try 6x and 1x if that didn't work for you. Well, similarly with 2 tangents squared, so you know with 2 tangents squared, one of them's got to be 2 tangent. And again, if you want to go to the side and let u be tangent, right, the other way to do it is if you let u be tangent, you're just factoring 2u squared, 2u squared plus 9u minus 35. Just make sure if you do it that way that you replace u with tangent at the end. I like to keep it just with tangents, so I'm just going to leave it with the left-hand side. So one of them's 2 tangent, one's got to be tangent because that first term's got to give me 2 tangent squared. And now I'm looking at the 35, and so I'm like, well, I could try 1 and 35, or I could try 5 and 7, and one's got to be a positive, one's got to be a negative. All right, so let's try this. Let's see if this works. 2 tangent squared minus 14 tangent plus 5 tangent minus 35. So I got 2 tangent squared. That gives me minus 9 tangent. Now I'm really close, but I didn't need a minus 9. I need a positive 9 tangent. So instead of plus 5 minus 7, I'm going to go minus 5 plus 7, and then I'll have it. So minus 5 and a plus 7. Then I check that one. I'm like, oh, that's it. All right, so the rest of this section is we're going to be working with some identities now. So that's some factoring with trig expressions similar to algebraic expressions. Now we're going to get into the identities. We know the tangent, sine over cosine, right? We know the cotangent's the reciprocal. Cosecant's the reciprocal to sine, secant's the reciprocal to secant, cotangent's the reciprocal to tangent, so on. Now this one we haven't talked a whole lot about. This is, I call this the money formula. You will see this a lot. Sine squared plus cosine squared equals 1. So if you think about, let's think about like your unit circle for a minute, right? Where we have, our unit circle has a radius of 1. So this equation is x squared plus y squared equals the radius squared, right? So x squared plus the y squared equals 1. Well, if you remember, our x is our cosine on the unit circle. Our y is our sine. defined as the sine on the unit circle. And so we have cosine squared plus sine squared. In other words, I'm going to write the sine squared first, plus cosine squared equals 1. All right? So it comes from the equation of a circle there. Sine squared plus cosine squared equals 1. Well, I just want to make sure you know that doesn't just kind of appear out of nowhere, but that's one you want to definitely memorize. Sine squared plus cosine squared equals 1. Now, if you know that sine squared plus cosine squared equals 1, all these other ones come from that. So notice if I solved for sine squared, I get sine squared is 1 minus cosine squared. If I solve for cosine squared, I get cosine squared is 1 minus sine squared. If I take this sine squared plus cosine squared equals 1, I divide everybody by, let me divide everybody by cosine squared. Then what you get is sine over cosine is tangent. So you got tangent squared plus 1 equals secant squared. Tangent squared plus 1 is secant squared. There's the next one. So that just comes from it. That's just an alternate form of that if you solve for tangent squared. And then the last one comes from, again, from the money formula, I like to call it, sine squared plus cosine squared equals 1. If you divide everybody instead by sine squared this time, then you get 1 plus cotangent squared is the cosecant squared. So that's that one right there. Okay, so they all stem from that money formula, sine squared plus cosine squared equals 1. So if you can remember that, sine squared plus cosine squared equals 1, that'd be great. What we're going to do when we establish these identities is we're going to take the more complicated side and prove that it's equal to the other side. So like this first one, we have cosecant of theta times the tangent of theta is the secant. So we're going to work with this left-hand side, and we're going to work it down and show that it's equal to the secant. So here's some techniques. Number one, you can change everything into sines and cosines, and then here's some other ones. We're going to start out with that first one, okay? So let's change everything into sines and cosines. So we know cosecant is the reciprocal to sine, right? So that's 1 over the sine. We know tangent is the sine over the cosine. And again, we're just working with this left-hand side. You're working with the more complicated side. Notice how the sines cancel. And so we're just left with 1 over cosine. Well, we know 1 over cosine is the secant. There we are. We just showed that the left-hand side is equal to the right-hand side. We just established the identity by changing everything into sines and cosines. So that's your first approach to proving these, okay, is to change everything into sines and cosines. Let's do another one where we actually use factoring, the second one, to simplify the expression. So let's do that for this next one. This top one is sine to the fourth minus cosine to the fourth. That's a difference of squares. You remember difference of squares? A squared minus b squared factors into a minus b, a plus b. Remember that? So sine to the fourth, it'd be, so if you have a to the fourth minus b to the fourth, it'd be a squared minus b squared, a squared plus b squared. Right? So that's what we have here on the top. I'm going to work with the left-hand side here and show that it's equal to the right-hand side. So I have sine squared minus cosine squared times sine squared plus cosine squared. And this is all over. My denominator is still cosine minus sine. Okay, so I factored the top, difference of squares. And I'm trying to whittle it down and show that it's equal to the right-hand side. Okay. Now this sine squared minus cosine squared, this is still difference of squares, so I can still factor that. Sine minus cosine, sine plus cosine. And I still have sine squared plus cosine squared. And then the denominator, I still have cosine minus sine. Okay. Now notice in my denominator I have cosine minus sine is almost, it's not quite sine minus cosine. So could I take a negative out of my denominator? That's my approach for this one. And I'll say, sure, if I took a negative out, that'll change these signs. Then I would have negative cosine plus sine. See how that's the same thing if I distribute that negative back? Up here, let me rewrite everything up here. Sine minus cosine. Sine plus cosine. Sine squared plus cosine squared. Alright, so notice sine minus cosine, sine minus cosine. So that's gone. And what I'm going to do is I'm going to take this negative up top. Okay, so now up top I have a negative. Then I have this sine plus cosine. And then this sine squared plus cosine squared. Remember, this is the money formula right there highlighted. What is sine squared plus cosine squared? Hopefully if you haven't memorized it yet, you get that cemented in your brain that the sine squared plus the cosine squared is 1. That's 1. And so we have negative sine plus cosine. I'm going to write that. I'm going to write it cosine plus sine so it matches the other side. Equals negative cosine plus sine. See how they're the same? So we worked the left-hand side down until we showed them that they were the same. All right, with this next one, we're going to go ahead and factor again as our technique. So notice in my numerator, and again, I'm working with the left-hand side. I'm trying to work with the more complicated side and show that the left-hand side is equal to cotangent. So notice my two terms. I have cosine over here, and then I have that minus 2 sine. What I'm going to do is I'm going to take a cosine out of each of those. And so I'd be left with 1 minus 2 sine. See how if I distributed that back, I'd have the same thing. And on the bottom, I have cosine squared minus sine squared plus sine minus x. So this, here, let me write it. Cosine squared minus sine squared plus sine minus 1. Now what I'm going to do is I'm going to go ahead and I'm going to replace cosine squared right here. Remember, I know sine squared plus cosine squared is 1. So what is cosine squared? Well, if I solve for cosine squared is 1 minus sine squared. So that's what I'm going to replace. Cosine squared gets replaced with 1 minus sine squared, because sine squared plus cosine squared is 1. Okay, let's see what we got now. So I'm going to make a replacement so I have all signs on the bottom. So I have 1 minus sine squared. Oops. That's my cosine squared. And then I have a minus sine squared on the bottom, plus a sine, and then minus 1. And let's see what we got here. So top stays the same. And then on the bottom, notice I have 1 minus 1, so that's gone. I have a negative sine squared minus another sine squared. I have negative 2 sine squared of x plus a sine of x. And so notice I can take out a sine from each of these. I can take a sine out of each of those. So numerator stays the same. denominator, I'm going to take a sine out, and I have negative 2 sine x plus 1. Well, that's the same as 1 minus 2 sine of x. You see how those are the same right there? So those will cancel. So I'm just left with cosine over sine. Well, we know cosine over sine is the cotangent. And that's what we're trying to show. We're trying to show this is equal to, remember, the cotangent. So there we are. Cleans up real nicely for us. The third one here technique is to get a common denominator. So that's what we're going to do on this one, is get a common denominator. Now notice I have cotangent here. So what is cotangent? Let's put it in terms of sine and cosine. We know cotangent is cosine over sine. And then we got this 1 minus 2 cosine squared all over sine cosine. And what we're going to do is get a common denominator. So notice we have a sine and a cosine right there. But on the left-hand side, we just have a sine. So we need to give it a cosine, top and bottom. Okay, so what we got is a cosine squared plus 1 minus 2 cosine squared. Now this is all over that sine cosine common denominator. Okay. And now we'll combine like terms. I got cosine squared minus 2 cosine squared is a negative cosine squared. So I got 1 minus cosine squared all over sine cosine. If you remember 1 minus cosine squared, don't forget this money formula. It seems to always pop up. Sine squared plus cosine squared is 1. So what's 1 minus cosine squared? Sine squared is the same thing as 1 minus cosine squared. See how 1 minus cosine squared is sine squared? So we're going to replace that with sine squared. So we got sine squared. I'll write it sine times sine on the top, and then we got a sine times a cosine on the bottom. So one of the sines cancels. So we're just left with sine over cosine. Well, guess what? That's tangent. So tangent, and that's where we want to get to, is equal to tangent. So we finished that nicely. Again, that was getting a common denominator. This next one also will want us to get a common denominator. We have a 1 plus sign right here. And so I need to give the other one a 1 plus sign as well. So we have cosine over 1 plus sine. Okay, so let's go ahead and give this a 1 plus sine, top and bottom. Give this one a cosine. And so it looks like we have cosine times cosine. I got cosine squared plus over here, I'm going to go ahead and FOIL this. So I have 1 times 1 is 1. Oops, come on, that's not working. 1 plus sine plus another sine. So I have 2 sine. And then sine times sine is a sine squared. And this is all over our common denominator of cosine 1 plus sine. Okay, and let me write it this way. Let me write the sine squared next to the cosine squared, because I know that's the money formula. And then plus 1, and then plus the 2 sine. Again, remember, this is 1, right? Sine squared plus cosine squared is 1. So we got 1 plus 1 plus 2 sine x over cosine 1 plus sine. And so we got 2 plus 2 sine x. This is all over cosine 1 plus sine x. I can take a 2 out of both of those on the top, so I'd have 1 plus sine. Let's see how those cancel when we come over here. So I have 2 over cosine. In other words, 2 times 1 over cosine. Well, that's 2 times the secant. And that's where we wanted to get to. We wanted to show that it was equal to 2 secant. All right, so this one we got tangent plus cotangent. Notice we already have a common denominator. And so what I'm going to do is just go ahead and put this in terms of sines and cosines. So I know tangent is sine over cosine. I know the cotangent is cosine over sine. And these are all over secant, which is 1 over cosine, times cosecant, which is 1 over sine. Now on the top, I have, notice now I need to get a common denominator in the top. So I got to give this one a sine to match the other side. And then I got to give the sine a cosine. And so this becomes sine squared plus cosine squared all over this common denominator. All over the common denominator of sine, cosine. And then this is all over 1 over cosine times 1 over sine. In other words, 1 over sine cosine. It's the same thing, or cosine sine, right? Well, remember, sine squared plus cosine squared, this is 1. So what we have is we have 1 over sine cosine. This is all over 1 over sine cosine, right? And so you got, it's kind of like 2 over 2, you got 1, right? Or if you want to be proper or technical about it, you can multiply by the reciprocal of the denominator, sine cosine over 1. But that means you got to do it to the top. And so you got sine cosine over sine cosine, which is just 1. And 1 equals 1, and that's what we want to get to prove that. All right, this last one you can, if you look at this last 1 plus sine over cosine, you could do either side on this, right? Like the question is, who is, oops, who's the more complicated side? Let's work with the right hand side, and we'll show you. You could work with either side on this, but let's work with the right hand side. And the last technique that we didn't talk about is multiplying by a conjugate, right? So we've put everything in terms of sine and cosine. Notice this is all in terms of sine and cosine. The second one was a factoring. The third one was getting common denominators. And then this last technique is to multiply by the conjugate. Well, what's the conjugate of 1 minus sine? Conjugate is 1 plus sine. So you can multiply, well, if I multiply the bottom by 1 plus sine, its conjugate, that means I got to multiply the top by 1 plus sine. And this time we're working with the right-hand side. And we're trying to show that the right-hand side, so only work with the right-hand side, is equal to the left. Okay. Now when I FOIL this, I'll have 1 plus sine minus sine squared. Notice those are gone. So I have 1 minus sine squared. So I have cosine, 1 plus sine, all over 1 minus sine squared, right? Well, if you remember 1 minus sine squared, remember that sine squared plus cosine squared is 1, right? So what is 1 minus sine squared? Well, 1 minus sine squared is just cosine squared. 1 minus sine squared is cosine squared, so I'm going to replace that with cosine squared. Now notice one of these will cancel. I have 2 cosines on the bottom, 1 on the top, so it leaves me with 1 left over. So this just ends up with 1 plus sine over the cosine. And notice how that's equal to the left-hand side. Done, right? Now, could we have done it? Could we have done it with the left-hand side? Sure. Sure, we could do it with the left-hand side. So let's see if I can. Maybe I'll do it over here. So this time, let me see if we go over here. Let's do the left-hand side. So if you're working with the left-hand side, then we're going to multiply by the conjugate of 1 plus sign. So I'd have 1 minus sign. If I do it to the top, got to do it to the bottom. And so we have 1 times 1 is 1, plus sign, minus sign squared. This is all over. I have a cosine and a 1 minus sign. Sine minus sine, that's gone. So I'm left with 1 minus sine squared in my numerator. And remember, sine squared plus cosine squared. Let me erase this. I kind of made a mess of all this. Is 1. So what's 1 minus sine squared? 1 minus sine squared is cosine squared. So what is 1 minus sine squared? It's cosine squared. So we're going to replace that. And then notice one of these cosines cancels and just leaves us with 1 left over. So I have cosine on the top and 1 minus sine on the bottom. And that's where we wanted to get to, right there. That's the right-hand side. So we just matched it. Hopefully that kind of gets you going with some trig identities. Thanks so much for taking notes. See you next time.